Okay. All right. So out of respect of your time, I want to go ahead and get started. I guess those who are going to continue to join will continue to join, but I'm going to start on time. And thank you so much for joining us this afternoon, for coming to learn more about this metal laser powder bed fusion technology from One Click Metal, and how it benefits education, research, and all of industry pretty much. My name is Lisa Brown. I'm your hostess from Impact Systems Engineering, and we are also hosted by Zach Kelly, one of our senior designers and an applications engineer on the metal side. We're also going to be joined by a little bit later by some of our users and guest friends over from New Mexico State, Dr. Gabe Garcia and Reyes Luceto. And then finally, in fact, before I mention him, I would like you to hold on to your questions if you don't mind. It's just the way we'd like to do it, and ask questions and do the Q&A at the end. Using the Q&A icon up at the top, I will remind you later as well, but there's a Q&A little icon right by the chat box, and we'd like you to use that for questions. And joining us for the question part will be Michael Steger, who is directly from One Click Metal. But let me start out by telling you a little bit, hey, Michael, start out by telling you a little bit more about who Impact Systems Engineering is. We are a Texas-based engineering firm, been in business for more than 35 years. And these are some of the print services that we offer, not only on the metal side, but polymer as well. Whether it's a prototype, one-off, or batch production, we can help you out of our Impact Lab, which is right across from our headquarters in Temple, Texas. We call it our Impact Additive 3D Lab. And we also offer engineering design services like CAD and 3D modeling, and soon to be 3D scanning as well. On the virtual simulation side, we offer finite element analysis and computational fluid dynamics, and then also structural engineering and topology optimization. On the training, we invite you to go and look at our website. There's a nice calendar and schedule of events there. If you have any drafters that would like to brush up on their geometric dimensioning and tolerancing, for instance, go check out the GD&T schedule on our website. As far as the technologies that we sell, we not only provide these technologies, we also are users. And I think that's pretty huge as a reseller. We want to help add value to and protect your investment, right? So we are users in our production lab in Temple, and we offer fused filament fabrication, also widely known as FDM. Also some powder-based systems like selective laser sintering, multi-jet fusion, binder jet, and what we're talking to you today about, which is the laser powder bed fusion. We also offer resin technologies, direct energy deposition, and we also offer some robot cells that come with curriculum, and they're offered for education, for additive manufacturing, and for welding. And then we also partner with some robot arm integrators, as well as a platform for large format additive manufacturing. Now, on the post-processing side of things, we not only sell the technology, but we also can offer you depowdering, surface blasting, vapor smoothing, and then color and dye as well. Just to show you a brief snapshot of some of the wonderful partners and vendors that we work with. We find it very valuable to work with these partners because they offer and support the same type of valuable support that we offer you. And we're going to focus a little bit more on One Click Metal today. So let me talk to you a little bit about who they are. If you haven't heard of them, they are a spinoff from Trumpf. Now, Trumpf has been doing metal for many, many years. They're out of Germany, and they actually made the first prototype machine at the Trumpf location. However, in 2019, they branched off into their own company, One Click Metal. And you can see that in 2021, Index Group took a majority of the share because they saw the vision that they had to provide metal 3D printing to more users. Typically, it's a very expensive endeavor and can be a bit intimidating. So anyway, One Click Metal is all about providing it to more users. And even though sales in the US just started in 2022, they are in several universities now, and a lot of industry has installs as well. All right, so we're going to pass it over to Zach, and he's going to tell you a little bit more about this cartridge system and the easy workflow from the Bold series system.
All right, I'm Zach Kelly. I've been with Impact Systems now as of last week, 15 years. I'm one of our senior mechanical designers and also one of the application engineers on more of our metal side of printing. So, as Lisa said, today we're going to be going over the One Click Metal series. It's the Bold series, as they call it. And we're going to be discussing these two machines right here and right here, the imprint and the impure. And then we'll get into some of the basics on some of the materials that come with this Bold series. Okay, so we'll start with the powder cartridge system. Um, these machines, they've got two different cartridge systems. One's a supply system and one's an overflow system. They are both sealed cartridges, so you're not going to have this metal powder that you're handling just out in the open. So it's extremely clean, it's extremely safe. And this is why a lot of the universities that we've put these machines into, they're really happy about this metal and how clean it is, because a lot of the other metal machines out there, they're not that safe, and you got to wear a full bunny suit, full PPE system. Now, these two different cartridges being sealed, it might be easy to mix them up. You've got two different color coding systems. You've got a green on your supply system. You have a black on the overflow system. These are both integrated with an NFC tag built into it. So the two different machines we're talking about here, they know where each one of these cartridges is located during the process of this. Okay, so we've got two cartridges. It's extremely safe to use. So here's a few of the different materials that are available out there. You've got aluminum, you've got a couple different stainless steels, 316, 17.4. You've got an M300 tool steel, 625 and 718 Inconels, and then you got your TI 64 for titanium. Now, this is an open platform, so if you've got your own material that you want to be testing, we can work with you with that. We can also get with One Click Metal and work that way as well. So, a little about these cartridge systems and their locations. Okay, I'm going to turn a laser pointer on here and kind of point some of these out. So your supply system, this on the left-hand side is going to be your Imprint Plus, so your printer. One on the right-hand side, this is going to be your Impure Pro or your depowdering slash sieving station. So your supply canisters, these are going to be the material that you're printing with, not only fresh, new virgin material, but you can also recycle a lot of the material that you're printing with. You run it through a sieve and you place this back up here in your supply location. You can put up to 5 different cartridges in here at a time, and you can also swap these out mid-print if one of these runs out empty, okay? Your overflow cartridges. This is basically just to catch the excess powder during the printing cycle, also during your depowdering cycle. And we'll get into all this a little bit later. I've got a couple of videos I'm going to show you of how some of these processes work. So I mentioned safety and clean system with these cartridge systems. So a lot of the other metal powder machines out there or technologies out there, they're dirty. I mean, you look around one of those printers in like a legit shop that's running them, you're going to see metal powder all over the floor, all over the machines. This one-click metal machine, it's extremely clean. So you can see in a couple of pictures over here on the right, once these machines like have the prints going on and you're moving your cartridge and your print over into the depowdering station, it's very clean. You don't have loose powder just floating all over the place. You're not depowdering in an open environment. It's all closed up, it's all nice and sealed. So you're not required for all this extra PPE system like some of the other brands out there until you're starting to work into more of your material changeovers. If you're trying to swap to a different material in your printer, that's a good time to go ahead and put your respirator mask on, your gloves, everything, because you will see a little bit of powder there, but it's very, very minimal. The entire process is extremely clean working this printer and printing it. So let's talk about where we are printing. So we're going to print inside of these build modules. It's going to come in during the printing process. It's below the print area. Your print bed is built into the top of that build module, and it's going to lower down as it's printing more across the top of it. There's 3 different styles. You get your standard build module, build size 150 millimeters by 150 millimeters by 150 millimeters in the Z height, which is roughly 6 by 6 by 6. You also have a heating module, which is the same build size as your standard. It's just adding a heating element into that build case. It can reach temperatures up to 200 degrees Celsius, and it preheats it in less than an hour. So it's relatively quick. And then lastly, you have your lab module. Your lab module, it's going to allow the use of different materials without contaminating the rest of your system. Now, the build size is a lot smaller. Your build plate's going to be 78 millimeters by 53. Your build height in the Z is going to be 90 millimeters, so roughly 3 inches by 2 in the XY and 3.5 inches in the Z. Okay. So here's a little deeper dive into that lab module. Let's say you typically run, I don't know, 316 in your machine. So you're going to use your standard build module for that. But we want 1 or 2 small parts that we want to print in titanium or aluminum. That's where this lab module comes in. You can fill this lab module with the small amount of material that you're wanting to use and just print 1 small print on that, and you have your own powder supply in this same module. It's all incorporated. So you got a supply area here. You have your build plate or substrate plate, as they call it. Again, it's smaller, but it's good for swapping to a quick material change and not having to clean your entire printer and depowdering station just for this material. Also, you have this miniature overflow container here, all contained in this 1 module. Here's a great cutaway view of this. So you've got your powder. As your powder is going up, as your part is printing here on your build plate or your substrate plate, this is going down. And then any overflow from your wiper is going to go down here into this overflow chamber. Nice, neat, clean, and very simple. So this is one great thing that One Click Metal has done extremely well, in my opinion. I've been around a bunch of different machines. With any 3D printer out there, you're going to have CAD files. So you've got your 3D CAD files. Okay. Next, we're going to send that to some sort of slicer. For One Click Metal, we're going to use Autodesk NetFab or Fusion 360. This is nice for universities because a lot of times Autodesk gives you all licenses for both of these. So you're not having to pay for some outsourced license to run this particular machine. This M1. So this is an app that you can download to your phone. You can use this on a computer or a tablet. And this is how you can see a lot of the different setups that's going on in your imprint or your printer. So you can see your powder supply. How much powder do I have in each one of those 5 cartridges up at the top? Do I have enough gas? And you can pretty much run your printer. You can even see like an integrated camera system to see how your print's coming out as it's printing. So you start your print in Imprint. This is where you can also do some machine setup, start your job. If you need to refill any of those supply cartridges, you can do that on the fly. You pull your print out of the printer, go to your Impure Pro / depowdering station. This is where you're going to unpack your prints, unpack your parts. You're also going to sieve all of your powder in this same machine. So 2 machines, simple workflow. Once you pull your prints out or your parts out, that's when you start your post-processing, and the sky is the limit. So cut your parts off your build plate, remove any supports. If you want to polish your parts, sandblast them, heat treat them, pretty much anything you'd like to do, this comes in your post-processing options. So there's also a YouTube channel for One Click Metal. It's AM Academy. They've got a big variety of different topics like part design, parameters, PPE, how do you clean the machine? So there's a big like envelope of different videos that you can watch on these systems. Education is the key to sustainable use of metal 3D printing. All right, let's jump into the machines a little bit. So here's your imprint. This is the printer. And I'll kind of go like create a roadmap for you and go through some of the different chambers inside of this. Up here in the top, you're going to have your powder supply. So again, 5 supply cartridges of fresh powder that's going to supply your printing bed. Right below that powder supply, you're going to have this gas filter. Very simple to replace. And why do I say gas? This is going to be like your inert gas, so like nitrogen, something like that for during the printing process of it. Let's jump over here to the processing chamber. This is where your prints are going to be happening. This is where your laser powder bed fusion process is happening. You've got a 200-watt laser. It's a fiber laser. It's got a 70 micron focus diameter. This is where all the magic's happening right inside of this process here. Down below, this is where your build module goes in. You can see these 2 green handles. Anything on this machine that has something green on it, that's where it's safe to put your hands, okay? So notice these supply cartridges, they have a green handle, green door. You're going to be in and out of this door, adding more supply cartridges. Removing your build module, these 2 green handles, that's how you remove it. You flip those modules up, get a trolley, move it over. Quick and clean. Again, your build module, it's 150 millimeters by 150 millimeters by 150 millimeters. It has adjustable layer heights for your builds. You set that up in your print profiles, and you can go down to 20 micron layer heights, which is pretty nice. Power requirements, 230 volts. Again, you're going to need nitrogen for a protective gas while you're doing your printing. So now the Impure Pro looks very similar, still has the nice, pretty green doors and black doors. This is where you're going to be doing all of your unpacking of your parts, removing your build from this build unit down here. And this is also where you're going to do your sieving. Okay, so I'll kind of roadmap this for you also. We've got where you're unpacking your build. This is sealed. You've got rubber gloves that are sealed to the door, so you're not getting that powder in your face where you have to wear a respirator mask like some of the other powder systems. Okay, there is an external vacuum connection over on the right-hand side of this machine. So once you remove all the powder from your build, you can use that vacuum to clean up any excess powder so you're not getting metal powder all over you. Down here is going to be your sieve. So overflow cartridge in the bottom right. You can take this once it gets full, place it in the top. This down here in the bottom is going to be a supply cartridge. This is what, once it gets full, we're going to stick that back in the printer and reuse that material for our print cycle. These machines, you will get a starter pack. And it's going to come with a few of the different supply interfaces, the overflow interfaces. And this is also where you can come up and get some of your build plates. These build plates are reusable. So we typically will cut our parts off the build plates, grind them down nice and smooth, and stick them back into the printer and reuse those. Okay. Another thing you'll use pretty often is this trolley right here. This is what you're going to use for moving your build module from your printer over to your impure, your unpacking station. That way you're not having to like just manhandle this thing and pick it up, and move it over into the next machine. So One Click Metal, when you do buy a machine or you're really looking at buying a machine, they have some great site prep guides. These are going to tell you exactly what you're needing to install these machines at your facilities. Okay, so we can actually lay this out based off of a room size that you may have and put this into a visual effect like this one here. They also have a really thought out design guide to help you design your parts and for best orientation, good supports to get your most successful parts out of the machine. All right, let's go into an application. If y'all been to any of the trade shows where we've been presenting, or even One Click Metal's been presenting, I'm sure you have seen, you can see it, this gear profile. It's just a neat little keychain. It's got a bunch of gears. It's been printed in place. I'm going to go through a 6-step process on how this was printed. Okay. So step 1, you obviously got to get your CAD data. Take your CAD model, put it into the slicer. We use NetFab here, so we would put this into NetFab, send it to the printer. The NetFab, that's going to be where you slice it. That's where you put all your parts into and build, like what your build's going to look like. Due to these particular parts here, you're not going to need any support. So we print these straight to the build plate. We can fit 22 of these into a build, and we hit print. So when we hit print, turn this laser pointer off, on this printer, it's going to add powder. You can barely see it in this sped up. It's going to be like a recoater that comes across really fast. It's going to spread powder. Your laser is going to go through and print your parts with that 70 micron focus diameter, and you're going to get really nice, clean geometries. They can be big parts, little parts, lattice structures. We printed this nice moving dragon on our One Click here at our facility. We've also printed some big parts, okay? But for this particular process, we stuck 22 of these in one build. You can print it in about 21 hours. Once it's done printing, you move your build module over to your Impure Pro, which is your unpacking station. You unpack, you basically are going to just like brush off this excess powder off of your parts here. And those parts, once you get down into your build, that's what we're going to be cutting off the build plate in a couple of steps here in just a minute. But this powder, this excess powder, sorry, I was looking at the wrong screen. This excess powder here, we sweep that over into this graded area over here. It goes down into an overflow keg. We take that overflow cartridge, stick it above the sieve, and re-sieve all of this. And we recycle and reuse a lot of this excess powder here. Okay, so don't just dump that or vacuum all this out, because it's going to get reused. All right, step 4, cutting your parts off the build plate. There's a few different ways you can do this. We have a bandsaw here at our office at Impact Systems. We basically have a jig fixed up to where we place this into the bandsaw. We let the bandsaw do its job and cut the parts off the support. Cuts the parts off of the build plate. And then we stick this part on a sander. And if you want to bead blast this, you can. If you want to sand blast it, you can do that as well. So this part also has another tool involved with it. So you can see there's a little fixture here to hold these parts. There's also a special looking tool in this drill bit. We take this drill bit, stick it into the gearbox, and what we do is we stick that and just spin it for about 30 seconds. Doesn't have to be that long. It's basically just to kind of deburr it and clean up anything um, inside of these gears. Okay. Lastly, you've got your finished parts. If you want to go in and like fine tune your particular parts, you can do that. You can polish them. We have a polishing wheel here. We don't polish these just because we feel the surface finish is good enough. Sorry, I'm a little close there. But the surface finish on these are absolutely beautiful. And this is extremely a clean process. All right, let's look at some numbers. So I said we can print 22 of these in a print or on a single layer on a build unit. They cost us about $23 a piece, 21-hour print cycle, so it's less than an hour per part to print this. And this is, we printed these in 316 stainless steel. Part density, it's solid. It's over 99.5% fully dense. And your surface finish, you're going to be a little bit less than 11 microns on a 20 micron layer height. If you go up to a bigger micron layer height, you can print it faster. But for these particular parts, we want them nice, clean, with a really smooth surface finish. All right, I'm going to turn this benchmark part over to Lisa again.
All right, thank you, Zach. You guys, I just have a couple slides here to talk to you a little bit about the capabilities from One Click Metal. This is the standard benchmark part, so I won't go through them item for item, but I do want to highlight a few things. For instance, where you bubble 1 is pointing the lattice structure. Just wanted you to notice that that is a 0.35 millimeter thickness on that. People typically use lattice structures for lightweighting, sometimes just for aesthetics. Now the threads in number 2, those were as printed. Now you can tap after if you'd like to, but these were actually as printed on that 316 part, and you can screw on those nuts right after. And then the other thing that I would like to point out is the functional integration in number 6. If you take a look at that top image, the lower left-hand corner, you'll see what looks like a little lock that was actually printed in one pass. So meaning if you design in enough clearance, thank you, Zach, for pointing at that. If you design in enough clearance, and once you blast away the powder that was not centered, then you have articulating parts, moving parts, parts inside of parts. The point being that you can do that. That is a benefit of laser powder bed fusion. In the lower image, you can see 4 different wall structures showing you different wall thicknesses, and starting at 0.3 millimeters all the way up to 1.5 millimeters. Same goes with the pins, where we have the smallest diameter at 0.5 millimeters, and it goes all the way up to 3 millimeters. Again, it's just a great standard benchmark part. Now on this second slide here, showing the benchmark part, I'd like to point out, let's go ahead and take a look on the bottom image at that, what looks kind of like a transparent channel, that green channel. It's really a good thing to point out that internal channels like cooling channels or any other complex geometries, you can design into the part and print it in that one pass, whereas traditional manufacturing would make that quite challenging or in some cases not possible, right? So that is something I'd like to point out. And in the top image, you can see some other internal channels that get really small. The smallest diameter you see there is 0.7 millimeters. Now, if you were to put all of these on an entire build plate, we were able to get 9 parts on one build plate. All of those parts were printed in less than 40 hours, and all of them had a part density greater than 99.5%. Now, that is some great part density. And then the cost per part would be approximately $59. Oh, that's quite all right. Just wanted to point out also that the layer thickness was 20 microns. So if you wanted to get a little bit faster on the time, then you can always increase the layer thickness as well. And surface finish is the last thing I'd like to point out on this slide. We were able to achieve less than 11 microns on the surface roughness. But this is a great slide right here just to give you a really quick image of where we fall. Now, when you're talking small to mid-frame laser powder bed fusion systems, typically you're going to see a range anywhere from 100K all the way up to $1 million. Some systems do grow greater than $1 million when you're looking at large components or very large mass production. But this right here, where the green arrow is about where we fall. So if you want more information on that, get with your field service rep, your field salesperson like myself or any of the ones at Impact Systems, and we can give you a line item and of course talk to you about about what material you'd like to start out with. On the final slide, I'd just like to summarize one more time. Zach was talking to you about the safe closed cartridge system, about the build modules. You have options on those, the small footprint, the familiar data preparation software, Fusion 360 and NetFab. Of course, there's a fast learning curve. Our customers were able to install and get going within a week's time frame. Really amazing fast learning curve. And of course, just wanted to point out again that you've got a great team here at Impact Systems that helps install the system. We're users. We're going to help support you along the way, make sure that we protect your investment. And of course, if you want to start out with just services, we have that available to you as well. But for now, I'm going to pass it on over to our friends from New Mexico State University, starting with Dr. Gabe Garcia.
Good afternoon, everyone. Again, my name is Gabe Garcia. I'm the Assistant Dean of Student Success and Experiential Learning in the College of Engineering at New Mexico State University. I'm also the Director of the Ag Innovation Space. The Ag Innovation Space is the manufacturing arm of the College of Engineering. In 2018, we invested over $800,000 in equipment for the facility and are currently going through a $3 million renovation. Part of that renovation includes the addition of metal additive manufacturing capabilities. We had a budget of $500,000 to spend on the metal AM. We did look at a lot of powder bed fusion systems, but we're always faced with the problems associated with the safe handling of the metal powder. We've been working with nylon SLS printers for over 4 years, so we have a good understanding of the difficulties associated with working with powder. There are systems out there that certainly minimize the handling of powder, but are generally very expensive. Our desire was to get 2 printers so we could easily manufacture parts with 2 different materials. The One Click Metal printer and the processing system definitely stood out from all the other systems that we looked at, and the big reason was the seamless and safe material handling capabilities of the system. The cost, safety, and the efficiency in handling the metal powder were critical factors in our decision to purchase the One Click printers. Next, I'd like to introduce Reyes. He is our full-time employee in the College of Engineering, and he operates our printers for us. Reyes.
Good afternoon, everyone. Like I said, I'm Reyes Pacetto, pretty much the shop lead supervisor down here in the Ag Innovation Space, which is our shop area, which is additive and subtractive manufacturing area that we have, and that's where we did put the One Click Metal printers down here in the shop. To continue on what Gabe had spoke about, we've been playing with the SLS printers, nylon printers upstairs in another room, and of course the safety factors in the university of handling the powder and the comparison from the One Click Metals to that SLS nylon printer that we have up there are just 2 different machines, just because like I said, the One Click Metal is a fully self-contained system, handling the powder from unpacking the powder, putting it in the machine, and just transferring to all the depowdering system compared to the nylon printer where we do get a lot of dust in the room. So the handling of this powder and these machines is way 2 different machines. We did end up printing that benchmark print that One Click Metal has done. Like Gabe said, we do have a 3/16 machine and an aluminum machine. We ended up just printing it in the aluminum. I don't know if you guys can see the part, but as they showed you in their slides, that's a part in the aluminum print that we've done ourselves here. And we do have the capabilities now with the metal printers that we do have here at New Mexico State University.
Excellent. Thank you, gentlemen. So at this time, I'd like to invite the participants again. Hopefully you see the Q&A icon up at the top of your screen. If you have any questions, please go ahead and enter them there at the screen, at the top of the screen in that Q&A session. And let's see here. I'm going to have Michael join us as well. See you there, Michael? Okay, perfect. Excellent.
Yeah.
And then Zach as well. Zach is there with us. So if anyone has any questions, this is the best time to ask them. We've got so many users and good folks on the call here. I do have one question being aimed at me here, asking what the lead time is for these machines. And I'm going to go ahead and say that so far, I've seen us be successful with 2 to 4 weeks on the lead time. Michael, is that something that you would agree with? Michael is out of our out of the U.S. office, the sales office for One Click Metal. He's in Indiana. I'm going to go ahead and invite Michael to go ahead and say a few words and speak to that.
Yeah, sure. So yeah, we have always machines also in stock here in the U.S. Of course, we produce the machines in Europe and ship them over to the United States. And so we also like try to have like machines in stock to have like really a short lead time to be able like to ship really fast machines and install machines really fast at our customers' place.
Wonderful. All right.
One question I get asked a lot is, how do you visualize the size of this machine? So if you can see this picture up here in the top right, they're a little bit bigger than a big size refrigerator. They're relatively small for a metal machine.
What was the question, Zach? I'm so sorry.
I generally just get asked, like, how big are these machines? Like, what are you expecting, kind of the footprint to be?
Okay, yeah, that's a good image.
I just tell them about the size of a big refrigerator.
Perfect. Right. Anyone else? This is the perfect time to ask. All right, well, I'm going to ask you guys over at New Mexico State, aside from the benchmark part, I mean, did you guys have any other plans on what you plan to print next, or what you're going to use your One Click Metal for?
So we did have a research team come in asking to print just some dog bones, but they want to print on the aluminum machine, but they want to do some testing with the dog bones first before they actually continue on printing the part in the aluminum machine that we have here. So we're going to go ahead and print those dog bones pretty soon for them.
Wonderful. How long would you say it took your learning curve on once you guys got it installed?
Learning curve, like I said, it's the biggest thing is understanding how to support a part for this type of machine. But One Click Metal and Impact Systems, they actually have print profiles already kind of set up to help with ladder structures to support a part. So having those profiles actually helps to just bring in a part and just orientate it, and you can apply those profiles, and it'll actually help support the part instead of you having to try to figure out everything. So that does help to really learn the process pretty fast to get to printing.
That's a wonderful point. Thank you for that.
Yeah. On the research side, these printers have really opened up a lot of capabilities. One of the difficulties with getting research grants is it's really hard to build that printer acquisition into the proposal. As long as you have that equipment available, then it's much easier to get the funding. So we do have already several researchers that have these printers in their proposals for our research funding to look at various aspects of the metal parts. Another thing is we do use it for our capstone projects. So we have a lot of capstone projects coming through. And the other thing is working with one of the researchers yesterday. As a matter of fact, he was very interested in trying to produce their own metal, uh, I guess what you call a formula to look at different types of materials and being able to, I don't know if you mentioned it that much, Zach, but that real small build volume that we can go ahead and just use that and have that self-contained and not having to clean out the machine and everything is definitely a plus. So I wouldn't be surprised if we're getting one of those very soon.
Very nice. That's great.
Can you see the Q&A questions, Lisa?
Yes,
not,
I can see
okay.
that we had the question of, does One Click Metal provide the printing parameters for the metal powders? And that is something that Reyes did address. And remember that this is an open system as well. So we also, they plan to collaborate and work with you if you have a specific material that you're wanting parameters developed for. So that is definitely true. I do see another question. How many impure do you need for multiple imprints? So in other words, the secondary station, do you have a rule of thumb, Michael, that you would say, or is that very specific to the application?
So yeah, of course, it's specific on the application. Depends on if you print like small parts and or if you print like bigger parts for several hours or days. So we say like usually between 3 and 10 printers. You can, of course, with the same material, use like 1 ampere to sift powder to clean the build jobs and stuff like that. So it's like between 3 and 10 printers for 1 ampere with the same material.
Okay. Let's see. What would the refresh rate be for the powder?
Like how many cycles of the same powder can you make?
So basically, so we can like all the excess powder, everything what you clean from the part, basically we capture and we can like sieve basically all the powder again. Of course, during the sieving process is like also why are we doing the sieving process? Maybe explain this a little bit. We have like it's a welding process. So during this welding process, you have like spatters and dirty stuff in the powder, what you want to remove out of the powder. So this is the reason why we sieve the powder through a sieving mesh, a fine sieving mesh, and to remove out of the good powder like these bigger particles, and to kind of like reuse again the whole powder. So of course we lose a little bit during this sieving process, like some bigger particles, but we can like we say like usually about like higher than 95% of the powder we can reuse again. And of course, like some powder stays also in the part, of course. Yeah. So also this is like first and then later in your part, and you cannot reuse it again. But all the excess powder you can sieve and you can reuse. Usually say like over 95% of the powder again.
Okay. Thank you for that.
That might be more towards like for the nylon printers. What do we use on the nylon? It's what, 80-20? So on that one, you do have degradation in the powder, but I don't think there's any degradation in the metal. Is that correct? So there is no mixture of 80-20, virgin powder to used powder. So
you're right, Gabe. The user may have been more familiar with the powder nylon for sure. So I tell you what, in an effort to stay right on task of our timing, I'm going to go ahead and say if you have any additional questions, please use my email address there. Give us a call at Impact Systems. Go check out our website. We have so many different offerings for you. I want to thank Gabe and Reyes for joining us today from New Mexico State. Michael, you as well from One Click Metal. Zach, wonderful presentation. Thank you to everyone who attended, and give us a call. Reach out to us. See if you have any other questions, please feel free to give us a call.
Yeah.
You guys have a good rest of your
I'm sorry.
Oh, yes. No, good.
Perhaps Reyes can give a little view of the shop. Our printers are just sitting inside of our shop next to our CNC machine.
If you have more time and you'd like to stay, please do. We would love that.
Just spin your computer. I mean, they're just sitting right next to our CNC machines. I mean, it's not.
Let's see if we can make him.
Yeah, so that's all
the whole frame here. Zach, are you able to put him on the whole frame?
Here, let me stop sharing and maybe it'll.
There we go. Let's see here. Tell you what, I'll take myself off of here. See if that'll help. Yeah, that's wonderful.
Like we don't have to have them in their own self-contained room, or we actually have them down here in our subtractor manufacturing shop. So just because they're a self-contained unit, so we're able to just keep them down here and not really dirty our shop. But that's pretty much our setup that we have. We have 2M prints and 2M pures just to make it easy for us and just keep each metal by themselves. But like Gabe said, we'll probably look into those other build modules if professors want to go into the research development and stuff. But that's your M pure right there. You guys can see it.
Do you guys have a vacuum for each printer?
So we do have one vacuum right now is what we have.
Okay.
Yeah. So.
Awesome. Okay.
It's all trash when it goes into the vacuum, so it doesn't matter. We don't need to.
Only when you start working with titanium, you don't want to cross-contaminate.
Oh, well, yeah.
That's pretty much inside of the imprint machine where the actual build module goes down here. I do have it in the sieving station, the impure right now. So if you guys are really wondering on what the build module looks like.
This is great because, oh yeah. See how those gloves are right there on the door? That's awesome. Right.
Thanks, Reyes.
Yeah.
Yes, thank you so much. All right. Well, we'll give back some more time this afternoon. Thank you guys again for joining us. And thank you all for presenting. You have a good rest of your afternoon and take care.
Thank you all.
Thank you very much.
Bye-bye.